Hello everyone and welcome to my YouTube video. My name is Parsh and today I am here to show you this AVR microcontroller based device which I have built. Now using this device you can turn on and off any appliance in your home, for example a fan or a tube light from your computer or from your mobile phone using Bluetooth. Now in this example I will be turning on and off this CFL from this Nokia 2700 Classic mobile phone. For more information on this project, please visit my blog at createanddevelop.blogspot.in. Well, I've got everything here set up for a demonstration, and the working of this device is very simple. The Java application in my mobile phone connects to this Bluetooth serial port module over here, which sends a signal, the same signal whatever is received by my mobile phone to this microcontroller, and this microcontroller is connected to this relay driver IC over here, which energizes or de-energizes this relay, and which switches on and switches off appliance over here. Now in this mobile I have created two Java applications for this purpose. One is device on and one is another device off, and this is for the device on is for turning on the device and device off is for turning off the device, as the name suggests. So this application connects to this Bluetooth serial port module over here and initiates a Bluetooth serial port profile, and its protocol is similar to what is in the computer's serial port, and which is similar to the UART used in this microcontroller. So there is no problem of the protocol. This is a Bluetooth serial port module, and it is very simple. Whatever command is or whatever the signal is received by the mobile phone, it simply sends the same signal to this microcontroller. Now this microcontroller over here is an AVR80 Tiny 2313, and it is programmed for UART. Now whatever signal is received by this Bluetooth serial port module, it goes to this microcontroller, and this microcontroller simply writes the value of the signal on its port B, which is right over here, and as you can see that I am not using any oscillator over here. Well, the default baud rate in the mobile phone or in the Java application is 9600, and all microcontrollers from AVR are set at default 1 megahertz clock, and at this clock speed the error percentage is very high, which is -7%. Now what I did over here is that I burned the fuses of this microcontroller to make it run at to calibrate its internal oscillator to 8 megahertz, which gives an error percentage of around 0.2%, which is perfect. Now calibrating the internal oscillator has many advantages. First of all, that it saves at least 3 components, that is the oscillator itself and 2 capacitors. And this LED over here, this is a blue LED, as you can see, and this is connected to the output of the UART of this microcontroller. Now the output of this microcontroller, the UART connections of this microcontroller is over here, which is the port D, and when UART is initialized, this port works for UART and not as a part of port D. And this LED lights, because we know that when serial port connection is ideal, it is high. So we are not transmitting anything right now, so the output of this microcontroller's UART will be high, which turns this LED on. I use it just to make it sure, just to confirm that the UART has been initialized. Uh, well, I have found some occasions in cases of power surges when UART is not initialized and the microcontroller is not ready. So in short, this LED tells me that the microcontroller is ready to receive the command. Now the another problem which I faced when using this thing is that when there are several other transmissions which goes on and which I do not intend to write on this port, because this is the output port and this will indeed turn on and off the device. So for that I programmed this microcontroller to listen for a specific number, which is 170 in this case. So the commands or the signals which starts with 170 only gets written on this port and nothing else. Now here we have the first pin of the port B, which is connected to this relay driver IC. So as we know, the value of the first pin of a port is 1. So whenever I send 170 and then I send 1, this will make this port make this pin go high, which will make this this input of this relay driver IC high. Now here I have gone one step further of what I have shown in the schematics. Instead of using a traditional this circuit, which consists of a diode, which is a surge protection diode, a transistor and a resistor, I have simply used this relay driver IC, and this saves a lot of components. Like for connecting one relay, you would require a diode, a transistor and a resistor for each and every relay you connect to. So this device can handle up to 7 relays or motors, and so if you plan to use 7 different relays with this device, it saves many components, and the calculation says like 20 components are saved by using this IC. And it also has an internal surge protection, the voltage suppression diode, so you don't need to connect any external diode or the protection diode, I would say, to this relay. Now this relay, the relay which you use is important. Well, I'm using over here is a DP-DT relay, which is dual pull, dual throw. But I'm just using it because this was a relay I was able to find which works at 5 volts, and so you can use an SPST relay. Now this relay says that it can handle up to 1 ampere of current on 120 volts AC, which says that this can handle the devices up to, or sorry, under 120 watts. Now this CFL over here only consumes 8 watts, so we are very well under limit. And also this LED is connected to the first pin of port B of my microcontroller. So whenever the pin goes high, this will light up this LED, and it will also make this input of this IC go high. So I think I have explained everything, I believe that. So let's go ahead and test the system. Now here is it. Let me go and turn on the device, and you see, as you see that the CFL lights up. Also this green LED over here, which is connected for showing that the device is, the microcontroller output is high or not. And let me go back and turn off it. And as you can see, it works. So I hope that you liked my video. For schematics, the microcontroller program, or for the Java application, please visit my blog at createanddevelop.blogspot.in. I have left the link in the description. If you have any questions, please leave a comment. I'll be glad to answer them. And thank you for watching my video.